This video will talk about proportions in the side splitter theorem in geometry related to similarity. So first we have a couple bullets here that we need to talk about in regards to proportions in the side splitter theorem, and then we'll move into some practice problems that have been on the Common Core exams for geometry. So this first bullet says similar triangles have congruent. If you don't know that symbol for congruent, then actually write out the word congruent. Congruent corresponding angles and corresponding sides are in proportion. So here on this right side we have a picture with triangle ACE and triangle BDE, where AC is parallel, that's what that symbol is showing us, to DB, which means that we have a pair of congruent angles, say C and D, because of alternate interior angles. And angle A is also congruent to angle B. So here's where we're seeing those congruent corresponding angles, where A matches up with B, D matches up with C, and then of course E matches up with itself. Corresponding just means matches up. So what we could do here to figure out this missing side length E is to set up a proportion, because corresponding sides are in proportion. So something such as small triangle over big triangle. We could do this the other way around, big over small. It does not matter as long as you're being consistent. So we'll take X and place it over the corresponding side. Then we'll take 4 and place it over the corresponding side. Notice that X and 4 are both coming from the small triangle, which we wanted because we put small triangle on top. Now I have to figure out the corresponding side. DE is where X was, so that's a square to E. Now if I look at my big triangle, I have square to E is that 14.8. Then for the other one, we have circle to E. Circle to E is 16.4. Now in order to solve this, we would just simply cross multiply. So we have 4x equals 14, I don't know what's going on with my 4s, 14.8 times 16.4. And then of course you could solve from here to find out the value of x. The next bullet that we need to talk about is about parallel segments in a triangle. This is where we get that thing called the side splitter theorem. It's just a fancy word for it. Here we have HJ is parallel to GK in both of these pictures. It's just showing you a difference in that HJ could be placed anywhere in the triangle as long as it's parallel to the base. And so from here we could set up a bunch of different types of proportions, such as a top over a bottom. Now when I say top, I'm talking about LH, over bottom HG. Then we could go with the right side top over bottom. Now we could also do something similar with whole over bottom. So the whole left side over the bottom left side, the whole right side over the bottom right side. Again, staying with consistency when setting up these proportions. Instead of whole over bottom, we could also do whole over top. Whole left side over top left side. Whole right side over top right side. And then there's one more that seems to be the trickiest for students to remember, and it's because we have to actually think about these in terms of triangles. Meaning this is your small triangle, and then we have the big, huge, gigantic triangle. So we could go small, whole side, meaning here, over the base. Here, small over base, small side over small base. So we're making kind of this L shape, side over base. Now we can do the same thing for the big triangle, whole side over whole base. Now the reason this tricks students up is because they try to go side over base equals side over base, not capturing the whole huge gigantic side. Instead they're capturing a bottom piece of the side instead of the whole side. So please don't make that mistake when you are setting up proportions. It's a very common mistake. The next thing we need to talk about, is actually an example. So here we have given triangle ABC if D is on AB and E is on BC, with DE parallel to AC. AD is 2, BD is 4, BE is 6. Find the length of BC. Now whatever you're trying to find, I always call that x. And I write myself a note here in the original problem so that I remember if I need to add 2 to it or subtract something away from it, whatever it happens to be. I always choose to call it x. Now, the thing here is we need to be consistent when setting up proportions. So I definitely know I'm going to have an x in my problem because that's what we're solving for, but notice how I had to put a big curly bracket on this right-hand side in order to find BC. So if I put a big curly bracket on the right side, I need to be fair to the left side. Now that length is actually something that we could talk about. 4 plus 2 to give us 6. So if we talk about this whole side 6 and the other whole side x, those could go on top. So we'll go with whole side on top. Over. Now if we look to see what's happening with the remaining parts, we have a top and a bottom and just a top over here. So because we only have a top on the left hand side, we're going to choose, whoops, I thought I had my pen. We're going to choose to use this top over here and this top over here. Now we got to, again, make sure we're matching up the correct parts. 6 goes with 4, so 6 over 4 equals x over 6. And then again, cross multiply. So again, we went with whole over top. 6 times 6 is 36, equals 4 times x is 4x. Divide by 4. So then x equals 9. Or in other words, BC equals 9. So again, you had options to set up this proportion, but the best and easiest option is to just go with whole over top. So this last bullet here is talking to us about determining the ratio of side lengths in similar triangles, especially when we're given a coordinate grid like this. We've seen a question like this one on a Common Core exam, so I just wanted to bring it up here with you guys. So it says that the ratio of corresponding sides are equal. That's why our sides are in proportion. Ratio is just a fancy word for fraction. And you can see that I wrote a lot of fractions below here. It says BE to CD can be written as BE over CD. So the first thing goes on top, and the second thing goes on the bottom, which would be equal then to BA over CA and EA over DA. Now these ratios, these fractions that I'm writing, are coming from the fact that we have one triangle over another. So in this case where I have BE, that's coming from triangle BEA over the other triangle, matching up those corresponding parts, CDA. So I can break that up into segments like BE over CD or EA over DA. So it says find the ratio of a pair of corresponding sides that are easy to count boxes for. So this would be something like either a vertical distance or a horizontal distance. Obviously it's not easy to count this diagonal distance for BE. So what we would do is count the boxes for, say, BA. 1, 2, 3, 4. So we have 4 over the total distance for CA, the matching part, the corresponding part. 1, 2, 3, 4, 5, 6. So once we have that set up, all we're going to do is reduce. And if you are using a TI Inspire calculator, it's very easy to reduce in your calculator. All you have to do is type in the fraction and hit enter. If you don't have a TI Inspire, then of course you can do what I'm doing, do the math in your head or on your paper. Just divide out by a common number, such as 2. So now we have 2 over 3. So the ratio of corresponding sides, BE to CD, is equal to 2/3. Alright, this first question that we're going to talk about, again, all of these are coming from Common Core exams, is very similar to the example that we saw at the first page of your notes. It says that we have this triangle, EB is parallel to DC, AE is 9, ED is 5, and AB is 9.2. What is the length of AC? So here we go again, drawing this big curly bracket on the right hand side, and we're going to choose to call this X because we're looking for that length, AC. Then, because I did a big curly bracket on the left side, I should do one, oops, I just said that backwards. Because I did one on the right side, we should do one on the left side. 9 plus 5 gives us a total of 14. So now I'm going to pick apart the pieces that I should use. On the right hand side, I only have 2 pieces. I have a whole and I have a top. So on the left hand side, I have to use the same types of pieces, a whole and a top. Now we just need to set up the proportion. So give yourself a second to set it up. If you need to pause the video while you do it, please do so. Then I want you to actually solve it and determine which answer is correct. Remember, here we are rounding to the nearest tenth. So again, pause the video, set up your proportion, hit play so you can see if you're right, then pause again so that you can actually solve. Okay, so I chose to go with the left side first and then the right side second. You could have flipped this around, that's fine. I went with whole 14 over top 9 equals whole x over 9.2. So again, you could have flipped these fractions, both of them upside down, or you could have swapped their spots on the left and the right. Go ahead, pause the video so you can solve yours and choose the correct answer, then hit play when you're ready to see. Alright, so number 1 should end up with choice 3, 14.3. My work here is shown, so if you got stuck at any point in time, just double check your work with mine. Number 2, another Common Core question. It says the image of triangle ABC after a dilation of scale factor k centered at point A is triangle ADE, as shown in the diagram below. Which statement is always true? Now, when we have dilations of any scale factor, we end up with similar triangles. Just means that the corresponding angles are congruent and the sides are in proportion. So we're going to try to narrow some of these options down as far as our choices go in the correct answer, because again, we're looking for an always true statement. So here it says 2 times AB is equal to AD. Now, it might look like if we had, say, x here, that this would possibly be 2x. However, it says some scale factor k. It did not identify what the scale factor was. This is imposing or implying that the scale factor is 2, but we don't know that. We don't know if k is 2. Oops, I'm writing the wrong thing. K equals sign with a question mark, 2. We don't know. And so here we're going to actually cross off choice 1. The next question, or next choice, is telling us that AD is perpendicular to DE. Now, sure, it looks like we could have a right angle there, but it doesn't always happen. I could take a triangle that looks like this, triangle ABC, dilate it by some scale factor, I don't know what, some scale factor, say K, and make DE with A still. Now, it's very clear here that AD is not perpendicular to DE, which means that choice 2 is not always true. Sometimes, could be, possibly, but it depends on the original triangle that we are given. The next one says that AC is equal to CE, implying the fact that C is a midpoint. Now, again, it might look it, but let me give you a counter example. Say A, B, C, dilated again by some scale factor K, where we have D and E. Now, does it look true this time that AC is congruent to CE? Clearly, it's not. CE looks much larger than AC, which means that choice 3 is not always true. It could be, but not always. So then our last option is BC parallel to DE. Now, of course, we're hoping so at this point because we've run out of options, but it is true because if no matter what type of triangle I take and I dilate it by some scale factor from this vertex, then these two sides are always parallel, those two bases. It doesn't matter, again, what type of triangle we start with. I'm just drawing a bunch of them to give you those examples. These two bases are always parallel. So for number 2, we should be choosing choice 4. Number 3 is a question in which you actually have to read very, very carefully. It tells you that we have 2 lines that are parallel. AC is parallel to DB, and we have similar triangles, which mean that the corresponding sides are in proportion. So it says which equation is true. And all of these, as you can see, are sides and they're in proportions, but we're trying to figure out which one is actually true. So we're going to say that triangle AEC is the big and triangle BED is the small. So sometimes I might refer to big and small triangles, and that's what we're talking about because it's just based on the relative size. Obviously, AEC looks bigger than BED. So this first one says that CE, so that looks like we're taking the big and putting it over DE, the small. Now we have to not just assume that it's true, we actually have to check. EC is here, or CE, and DE is here. They're both on the back end of these two triangles similarity statements, like AEC, BED. They match up. Okay, so we're good so far. Then we have the equals, and we go with EB. EB is coming from our small triangle. So now we're going with small over EA, big. Sure, this side matches up. BE does match with EA. However, we cannot have this happening where we go big over small, small over big. This second fraction should be flipped upside down in order to make it true. So number 1 is false. Number 2 says that AE, okay, so that's coming from big, over BE, small, and yes, AE does match with BE, equals AC, okay, big, over BD, small. Whoa, wait a second. Big over small equals big over small. That's good so far. Now let's just again double check to see if the sides match. AE, BE, perfect. And then we have AC on the outsides, whew, and BD on the outsides. Perfect. So number 2 is actually our choice. Now I just want to talk to you again about why maybe number 4 is not. Number 3 is not either. I just can't see half of it with my writing over it. So I'm just sketching out these letters again because I made them all messy before. And we're looking at choice 4. It says ED, so that's from the small triangle, over EC from the big, equals AC from the big, over BD from the small. So this is that case where we were not consistent. Small over big is not equal to big over small. So choice 4 is out. Again, number 3 is choice 2. Number 4 is one of those graphing questions in which we have to talk about ratio of lengths, like we saw at the first page of our notes. You can read this problem yourself, but essentially what they're telling you is that you have two triangles after a dilation center at the origin, and they give you a bunch of coordinates, and our goal is to figure out the length of the ratio, or the ratio of lengths rather, of BE onto CD. Remember when we talked at the beginning of our notes, we said the first thing goes on top, second thing goes on the bottom, and it matches up with the corresponding sides. BE is from our small triangle right here, which means that it matches with BA over, well, CD matches now with this bottom side AC, which then matches with the other set of sides on the left. Small is AE over big is AD. So if we can count boxes easily for any of these, then we'll be able to find our answer. And it looks like here C is kind of halfway in between a point. Now we could count boxes. It says that it's 4.5 away. However, it's easier just to work with these vertical heights, or vertical lengths rather, because they look like nice whole numbers. AE is 1, 2, 3, 4. So we said AE goes on top, meaning 4 over 1, 2, 3, 4, 5, 6 right here. Oh man, this is the same example as we saw on our first page. So then when we reduce, we end up with 2/3. Choice 1. Alright, number 5 says that we have two triangles that are similar, and it says which measurements are justified by this similarity. So it looks like every single time they are giving us AD, this top piece, over, or and AB, this whole piece. Then they give us AE top and AC whole. So it looks like we're thinking about top over whole here. So what we have to do in order to see which one is true is take these, set them up in proportions, and see if they are in fact equal. So we have AD top over AB whole, equal sign question mark, AE top over AC whole. Now you could solve this in one of two ways. You can either cross multiply and see if they're equal, or you can just simply reduce the fractions and see if they're equal. If we were to cross multiply, we have 3 times 12, which is 36, and we have 4 times 6, which is 24. These are not equal, so choice 1 is gone. Then the next one we have 5 over 8 equal sign question mark 7 over 10. Again, cross multiply. We have 8 times 7 is 56. 5 times 10 is 50. Not equal. Choice 2 is out. Number 3 says 3 over 9 equal sign question mark 5 over 10. Again, we're sticking with this top over whole. You could go whole over top if you choose to, but it just seems like AD is coming first every time, so we're sticking with that. When we cross multiply, we end up with 30 and 45. Again, not equal. So hopefully we've got choice 4 here as our correct answer. We have to double check to be sure though, in case we made a mistake earlier. 2 over 6 equal sign question mark 5 over 15. Cross multiply. 2 times 15 is 30. 6 times 5 is 30. So 30 equals 30, meaning choice 4. Alright, so number 6 here is telling us that we have triangle DEF as the image of triangle ABC after a clockwise rotation of 180 and a dilation where AB is 3, etc., etc. Which relationship must always be true? So we want to go through these options and we want to say, okay, what do we know about the things that are given? And it looks like in all of these options we're talking about angles. And we know that angles are congruent, which means that they are either in proportion with one another or set equal to each other. Now, choice 1 and 2 do not do that. It's telling us that if we were to cross multiply, 2 times the measure of angle A is equal to measure of angle D, meaning that the angle A is half the length or half the measure of angle D. Not true. They're congruent. Okay, so now we're checking the other ones. We could cross multiply these, but it would get a little bit messy. The easiest way to do this is to stack your letters on top of each other. It said that DEF is the image of ABC. So kind of like we did in the previous problem with side lengths, we can do the same thing with angles, as long as they are set equal in proportion with one another. So here it says that we have A over C, so that's kind of tough to talk about when they're coming from the same triangle, but as long as we're matching up the right sides, then we're okay. So we start with A, which means that on the top of the other one, we should have D. But it doesn't look like they did that. They have it flipped upside down. Because again, A matches with D, so if I read across, A should match with D. Now the next one has us going with B and E. Those do in fact match. And then C and F. Those do in fact match as well. Now we just have to make sure they're going from the right triangle to the appropriate triangle as well. So B is from small, E is from big, C is from small, F is from big. And again, that's just all based on looking at the sizes. So it looks like choice 4 is our answer for number 6. Alright, so we have ourselves 2 more quick questions here. Thanks for sticking out thus far. We've got 2 more to go and then you're free to work on your own. Number 7 says, to find the distance across a pond from point A to point C, a surveyor drew the diagram below. The measurements he made are indicated on his diagram. Use the surveyor's information to determine and state the distance from point B to point C. So I'm going to call this X. B to C is called X. So we're going to set up proportions here because remember, sides in similar triangles are in proportion. I just have to figure out what is consistent and what will help us find X. So I noticed that I have this side over this base. If you were to turn your picture, turn it kind of sideways here, I just made that L shape that we were talking about earlier. Side over base. So when I do the same thing for the big triangle, I need to talk about this whole side over the space of X. I'm going to turn my paper right side up again. So again, I've got 230 over base 120 equals this entire side length, 230 plus 85, which gives us 315. So 315 over X. Take a minute to solve that, round appropriately to the nearest yard, and then check back in with me to see if you have the correct answer. Alright, so for number 7, once we round, we should end up with 164. Number 8, we have triangle SCU shown below with points T and O drawn. Segment OT is drawn such that angle C is congruent to angle OTU. So this is important to actually mark up OTU right here. If TU is 4, OU is 5, OC is 7, what is the length of ST? So now typically we were talking before about how we could go like top over bottom, say 4 over X, 5 over 7. And you might think that you could do that initially. However, the problem arises when they said that angle C is congruent to OTU, because that means our triangles are kind of flipped upside down here. So it's important that we actually resketch these triangles, redraw them, so that they are facing the same way. So we're going to start with triangle SCU, where they tell us that CU is 7 and 5 for a sum of 12, and SU is a sum of X plus 4. Then when we redraw our little triangle, we're going to flip it around so that C is congruent to T. O moves now to the top and U stays where it was. So TU is 4. Now 4 is moving to the bottom because again we flipped this triangle, we essentially reflected it. So that again angle C is congruent to OTU. And then 5 moves to the top where OU is. So from here we can set up a proportion, like X plus 4 over corresponding 5. X plus 4 over 5 equals, go back to your big triangle, 12 over small triangle 4. 12 over 4. Go ahead and cross multiply, solve, and choose an answer, then check back in with me to see if you're correct. Alright, so for this one we end up with X equals 11, meaning that ST, which we initially called X, is 11. Choice 3 for number 8. Again, thanks for sticking through this video. At this point in time you may go to practice, you may rewind and revisit any part of this video, but enjoy yourselves while you're setting up these proportions. Just remember to be consistent.